Your cat has whiskers on its wrists. A dog's wet nose is a sensor. An owl's face is a dish. Some snakes can see heat. Sharks can feel electricity. A platypus can hunt with its bill in muddy water. And one tiny mole touches the world faster than you can blink. None of that is random. We usually think animals have the same basic senses we do: eyes, ears, nose, touch. But that's not really what evolution built, because once survival gets specific enough, a face stops being a face, a nose stops being just a nose, and a weird little body part that looks decorative turns out to be specialized hardware. These animals don't just have senses, they have hidden sensors, body parts quietly collecting information you'd never notice unless you knew what they were doing. And once you know what they are, you can't unsee them. Start with something almost everyone has seen, and almost nobody has really noticed. Cats don't just have whiskers on their face, they also have whiskers on the back of their front legs. They're called carpal whiskers, and they're real tactile sensors, not stray hairs, not decoration, not random fuzz. The face whiskers map the space around the head. The carpal whiskers extend that sensory system to what's happening right under the paws. That matters because close-range hunting is messy. When prey is pinned, batting back, twisting, or slipping under a paw, vision is not enough. The whiskers on the forelegs add tactile information exactly where the cat needs it most. And this is the hidden pattern of the whole video. Once an animal gets close enough to the thing it cares about, normal senses stop being enough. So evolution starts moving sensors into the contact zone. For a cat, that means whiskers on the legs. For what comes next, it means something even more obvious. A dog's wet nose looks like a cosmetic detail. It feels like one too, but that wet surface is doing a job. Dogs have wet noses mainly because moisture helps their sense of smell. Scent particles stick to damp surfaces more easily, and the moisture also helps dissolve those particles so the olfactory system can process them more effectively. So when a dog puts its nose into the air, or into grass, or into your hand, that damp nose is not just being a dog. It's improving the sensor. Cooling is part of the story too. Britannica notes that moisture on the nose also helps with thermoregulation. But the primary job is smell. That's what makes it such a perfect hidden sensor, because everybody notices a wet dog nose. Almost nobody thinks of it as performance equipment. And that idea, taking a normal surface and making it better at reading the world, shows up again and again in animals. Sometimes with moisture, sometimes with feathers, sometimes with heat, sometimes with electricity. An owl's face looks like a face, round, symmetrical, soft, almost human. But on many owls, that circular facial disc is doing something very specific with sound. The disc is a ring of feathers under muscular control that reflects and filters incoming sound as it travels toward the ear openings. In barn owls, it primarily funnels higher frequency sounds, and experiments simulating removal of the facial ruff show that taking it away causes a large drop in sound localization performance, especially for elevation. That means the owl face is not just a face, it's part of the hearing system. Sound hits the disc first, the feathers shape it, and the owl gets a better read on where the sound actually is. This is why owls feel uncanny. They don't just look alert. They're built to turn their whole front-facing head into a directional audio surface. And once you start seeing the facial disc that way, the expression changes. It stops looking soft. It starts looking engineered. Now the sensors get stranger. Pit vipers have a small facial opening between the eye and nostril called a pit organ. And that pit organ doesn't detect light the way eyes do. It detects infrared radiation, heat. The pit contains a suspended membrane packed with heat-sensitive receptors, and the geometry of the pit creates something like a low-resolution pinhole camera system. The result is not vision in the same way our eyes work, but it is a spatial read of thermal contrast that the snake can integrate with ordinary visual information. That's why the right way to think about a pit viper is not snake with good night vision. It's more like snake with a second targeting system. Warm prey against a cooler background becomes visible in a different channel. Not by color, not by shape first, by heat contrast. So the pit isn't some weird extra hole on the face. It's a dedicated sensor port. And that's the leap hidden sensors always make. A body part that looks minor suddenly becomes the whole story. If snakes push the idea into heat, Sharks push it into something even harder to imagine. Electricity. Sharks and other cartilaginous fishes have specialized sensory organs called the ampullae of Lorenzini. They appear as tiny pores concentrated mainly on the head and snout, but beneath the skin, they connect to gel-filled canals, ending in electroreceptor chambers. These organs detect weak electric fields in the environment. That means a shark can pick up the bioelectric signals produced by other organisms, including prey, even in murky water or at close range where vision is limited. That's an insane sentence if you really stop and think about it. A shark is not just looking for movement. It is not just smelling blood. It is reading tiny electrical differences through pores in its skin. So the shark's face isn't just a face, it's a sensor array. These are hidden sensors because the animal doesn't announce them. A whisker, a wet nose, a ring of feathers, a tiny facial pit. The most important hardware often looks like nothing. If sharks feeling electricity sounds like a fish thing, here's where it gets ridiculous. A platypus can do it too. The platypus bill is not just mechanically sensitive. Research showed that it is also an electroreceptive organ, capable of detecting weak electric fields. Later anatomical work found roughly 40,000 electroreceptors in the bill skin, arranged in stripes, along with mechanoreceptors for touch. That means the platypus isn't just feeling mud and motion with the bill. It is combining touch with electrical information from prey. This matters because platypuses forage underwater in murky conditions where vision is less useful. The bill gives them a way to read the hidden activity of prey directly, and that combination, touch plus electroreception, is what makes the platypus such a perfect hidden sensor animal. It looks bizarre, but the weirdness isn't random. The bill is not a duck imitation, it's a multisensory tool. And then there's the final boss of hidden sensors, the star-nosed mole. That strange star on the front of its face is not mainly for smell. It's a touch organ built from fleshy appendages covered in Eimer's organs, specialized tactile structures. A typical star has over 25,000 of these sensory domes, fed by more than 100,000 nerve fibers. When the mole searches for food, the star taps the world at extraordinary speed, around 10 to 15 touches per second. And the center of the star, the 11th appendage, acts like a tactile fovea, the high-resolution part that gets moved onto anything interesting for a closer read. That comparison is not casual. A fovea is what our eyes use for fine detail. The star-nosed mole has built one out of touch. And the speed is absurd. A mole can detect, identify, and begin eating prey in as little as 120 milliseconds. That is what hidden sensors look like when evolution pushes a system all the way to its limit. The star is ugly, a little alien, almost too weird to take seriously, but it's one of the most advanced organs in the animal world. And once you know that, the whole animal changes. That's the pattern. A cat extends touch, a dog turns moisture into better smell, an owl reshapes its face into a hearing device, a snake adds heat detection, a shark reads electricity through pores, a platypus has an electrosensitive bill, and a star-nosed mole turns its face into a scanner. None of these animals look like they're wearing technology, but they are. It's just biological. And that may be the whole point of Nature Edition. The world doesn't announce its best design choices. It hides them in plain sight. If you enjoyed the video, consider joining our community of the quietly obvious. Thank you.